Hi there, I'm Mr. Orr, and we will be talking about section 5.4 today in your algebra textbook. And this section is on solving compound inequalities. You may recall that we solved some basic inequalities, even if they became a little bit complicated, like 3x plus 2 is greater than 7x minus 6, for example. Or we had some that were more complicated than that, but here's what we basically did. Subtract 7x from both sides. You get negative 4x plus 2 is greater than negative 6. And we subtract 2 from both sides, and we get negative 4x is greater than negative 8. Then we divide by negative 4, but here, as you may recall, what's the trick? When you multiply or divide an inequality by a negative number, you reverse the direction of the inequality sign. So this becomes x is less than, 4 goes into 8 twice, the negatives cancel, x is less than 2. And when we graph that, we had, we had 1, 2 here, open circle because it's less than, but not less than or equal to, and it's less than, so it goes in that direction. And one little trick that we had to help you remember is if your variable is on the left-hand side, then the inequality sign is pointing the same way that your arrow is going to point, but only if the variable is on the left side. So be careful of that little trick. All right, now what we're moving to is compound inequalities, and those can be of the version and, or the version or, and we're going to talk about both. Let's say you have a couple of, well here, let's do this. Let's say you have x minus 3 is greater than or equal to negative 2. X minus 3 is greater than or equal to negative 2. And let's say x minus 3 is less than 4. Now let's solve each of those separately. So I'm going to add the 3 to both sides. I get x is greater than or equal to 1. And I add the 3 to this side, I get x is less than 7. Now when we go to graph that, x is greater than or equal to 1, 2, 3, 4, 5, 6, 7, 1, up to 7. X is greater than or equal to, so it's a closed circle because of the equal sign here. And that one goes this way. The other one is x is less than 7, open circle, less than goes back this way. Now, this is an and, which means that we are interested in those values which make both of those statements true. And that happens at this overlap, where the two lines overlap right in through here. Okay, so we could write that as, now that we've simplified these, we could write that as x is greater than or equal to 1 and x is less than 7. We could do it that way. Or we could write it as a single, what's called a compound inequality, in which case we put the x in the middle. And we put typically the smallest number over here. So x, reading from here, x is greater than or equal to 1 and x is less than 7. This is an and statement, and it tells you that x is right here in this range. And that's the only range x can be in. All right, so let's go back to the original problem now and look at how it might have been written instead of having it written that way. It might have been negative 2 is less than or equal to x minus 3, which is less than 4. All right, which is less than 4. Now you have a compound inequality. We're going to solve it right here without breaking it apart into two pieces. So this is going to be, we're going to add 3 here, we're going to add 3 here, and we're going to add 3 here, because remember we have two inequality statements. X minus 3 is greater than or equal to negative 2. X minus 3 is less than 4. So this is a shortcut. All right, so this cancels here. 3 minus 2 is 1, less than or equal to x, which is less than 7. Same thing we got before, but we actually did it all together in the same in the same inequalities which were wrapped up into a single statement. All right. Now you can also have ORs, inequalities that are ORs. And no relation to me, the math teacher, Mr. Orr. But let's find one here that would work for us. Let me see if I can locate one. Okay, a simple one here. Y minus 1 is greater than or equal to 7. Or y plus 3 is less than negative 1. All right, add 1 to both sides. We get y is greater than or equal to 8. Or y, and I'll subtract 3, is less than negative 4. Now, notice the big difference here between the ands and the ors. When we had an and, we had a range, and they met within that range. They overlapped. Here we're going to have y is greater than or equal to 8. 1, 2, 3, 4, 5, 6, 7, 8. Greater than or equal to 8, going this way. And less than, or less than negative 4, which is here, open circle going this way. Now they split apart. And that's the difference between an and an or. In an and, they come together and cross, and you get an overlap. In an or, they split apart, and there is a section in the middle, in here, between them, that cannot work as values. So what we're saying here is, either this will be true if x is greater than or equal to 8, or this will be true if y is less than negative 4, and either one of those is okay because it's an or. What's not okay is the stuff right in here that doesn't work for either one of them. All right, so that's and or. Now, let me see if there's more I want to do here just to make sure that we've covered. Yeah, if we were to write a compound inequality, let's see if we could do that with one of these. If you're given the graph and you are asked to write the inequality, let's see. Let's take this one here from negative 3 to 2. So I'm going to do 0, 1, 2, 3. Here's 2 I want, negative 1, 2, 3, negative 3. Now, I have an open circle here, and I have a closed circle at 2, and I have a line. Now that looks a whole lot like an overlap, doesn't it? So there's going to be an and I can write it with x in the middle, and I'm going to say x is greater than negative 3, because it's moving that way from negative 3, and it's an open circle, no equal sign here. And over here, it is less than or equal to 2. Okay, so now if I broke it apart, x is greater than negative 3, that's fine. X is less than or equal to 2, that goes this way, and the two of them are overlaps. All right, let's look at an or here, if we can find one. Here's one. All right, I have a number line, and here's a 0, and let's see, negative, let's do 0 moving forward this way, and, or, negative 3 filled in, 1, 2, 3, negative 3 filled in, moving this way. Now we have an or statement because they split apart, so I cannot write it as a compound. Remember, I had negative 3 less than x less than 2. I can't write an or that way. This is reserved only for and. So the or I'm going to write this way. X is less than or equal to negative 3, or x is greater than 0. And there's your answer. Okay, I believe that covers the problems I wanted to do for this section. They can get a bit harder with the algebra, but that's really the concept. So I'm going to stop this video, and the next video we will cover inequalities involving absolute values. Thank you very much.